Hello, everybody. Let's quickly solve these problems from the review packet. So I've got a graph here of, it looks like just sine theta. For what angles is r greater than or equal to root 2 over 2? So you know that sine of pi over 4 is root 2 over 2. So this height right here must be root 2 over 2. And so for all of these values between pi over 4 and 3 pi over 4, on the polar graph, you can see that the angle of pi over 4 is an angle that faces in this direction, because here's the origin, it's a 45-degree angle. And here's where it actually intersects the graph, so this distance is root 2 over 2. And all the angles increasing from there up to 3 pi over 4, which is 45 degrees this direction. So all of these points up here corresponds to values where that distance r is greater than root 2 over 2. Let's try the next one. So it says, let's graph this phase-shifted sine graph. So I've shifted it right by pi over 4. So it's going to start here at its midpoint at pi over 4 and go, let's extend the graph a little bit. I know the period's 2 pi, and so it's going to extend pi over 4 past 2 pi, so right here. So that means the halfway point is going to be here. And here's the upper and here's the lower. Oh, it goes all the way up to 1 and all the way down to -1. Okay, so here's what the graph looks like. Now let's go ahead and start plotting this over here as a polar graph. So I'm going to start by labeling some key values. Here's A, B, C. So A is at an angle of pi over 4, and the distance is 0. So that's A. B is 3 pi over 4, which is facing this direction. Its distance is 1, so it's all the way over here at B. C is at an angle of 5 pi over 4, which faces this direction. It's back at 0 again. So it's not really clear just from those 3 points, like what does this look like? Is it like straight out and back? That wouldn't actually make sense. So if you're ever trying to make sense of a situation and you've plotted a couple of points, you know, I want to understand what happens between A and B. So let's plot a point that's in between A and B. So pi over 2, I don't know the exact height here, but it looks like it's, you know, roughly halfway between 0.5 and 1. So when I'm facing up, looks like the point is approximately here. So if I'm going from A to here to B, again, maybe we're not so sure, right? Like, do I go straight up and then over? Like, you know, if I'm still having trouble visualizing it, let's plug in another point. Let's do one halfway between pi over 4 and pi over 2. So here's pi over 4, here's pi over 2. If I choose an angle that's halfway in between, let's see how far do I need to go. It looks like almost exactly 0.5, which would be about here. And so now we're really starting to get a picture. If I'm going to connect A to the next point, to the next point, to the next point, I connect A to this point, to that point out here. So, you know, maybe my graph is a little bit inaccurate in some of the middle bits, but at least this is going to be pretty close. So don't jump to conclusions. I was working with some students who somebody saw this and said, oh, is it maybe a spiral? You know, maybe it's a spiral, but don't immediately jump to a conclusion. Like, let's keep doing this process of making sense and checking. So I know that eventually I have to get back down here to C. You know, we might guess that because this graph is perfectly symmetric on either side of B, the polar graph should also be perfectly symmetric around B, and in fact it is. If we think about pi here, so pi is going to have the same r distance as pi over 2. So if I'm facing this direction, I'm going to go the same distance as when I'm facing up. So this is part of the symmetry I'm talking about. So it's going to kind of curve back along this way. And I could continue plugging in. So it's going to keep going back along that way. So it's sort of like this sort of shape. What about this lower section? Let's just choose one easy to check point. 7 pi over 4 is facing this direction. But when I'm facing this direction, my r value is -1. So I don't actually move 1 in this direction. I move 1 in the opposite direction. So this point ends up plotting right here at B. And if you sort of think about it, this point was 180 degree rotate. So sorry, this point is 180 degree rotation from that point. I know because I went from 3 pi over 4, which is here, and I rotated, 3 pi over 4 is here, and I rotated all the way around to 7 pi over 4, which is that way. So you can see the 180 degree rotation. So shifting horizontally here is sort of like rotating there. So this entire section is 180 degree rotation from this section. It's also, I've reversed the r direction. So if you think about taking this leaf and rotating it 180 degrees, but then if you think all the r's are reversed, that takes us right back over here. So this section just graphs the exact same points as that section. So this is what it looks like. If I think, if I don't just slavishly plot points, if I think about what's going on here, I know this should be a sine graph that's been translated in some way by pi over 4. You already know what the sine graph looks like. This is what r equals sine theta looks like. So here I'm getting a clue like, oh, maybe this actually should be a perfectly circular shape, which I'm now totally screwed up drawing. So imagine this is a perfectly circular shape. If I have a regular sine theta and I translate it by pi over 4, like how have I actually translated it? It looks like I've just rotated it by pi over 4, which makes sense because here the translation is applying to an angle. If it's a rectangular case, if I had sine x minus pi over 4, the translation is applying to the x-coordinate, which is why it's a horizontal translation. If I'm applying it to theta, it's a rotational translation. So this is an illustration of the kinds of connections and insights that I want you to be making in the quiz on your own. Let's do one more problem on the back here. So is the point with xy coordinates 2 root 2, 2 root 2 on the polar curve defined by this thing? Okay, so let's think about what makes this hard to think about. So I've got a point with xy coordinates, and I have, this polar equation that I'm not really sure what it looks like. So it's not obvious how would I tell what's on what. So I'm going to start noticing things. One thing I notice is that these xy coordinates are the same. So what I know is that it's got an angle of 45 degrees, and the distance here, well, we could calculate what the distance is. So if this is root 2 over 2 and this is root 2 over 2, I could calculate what that distance was. Does that actually lie on the polar curve? I'm not sure. But like one way at it would be, since I already know what the angle was, if I could calculate this distance, then I could plug in pi over 4 as the angle and check to see, do I get that same distance r? So that would be one way at it. Here would be a different way at it. Because I know that this point lies on an angle of pi over 4, what if I plug in pi over 4 here and get an r value? Then I could check to see, well, I guess maybe I'm just saying the same thing all over again. Yeah, so this is what we need to do. We need to somehow either convert this to polar or convert that to rectangular. So let's go ahead and do the converting this to polar. I think that's easier. So if this is root 2 over 2 and root 2 over 2, let's calculate that length. So I'll have r is the square root of root 2 over 2 squared plus root 2 over 2 squared. So root 2 over 2, when I square it, is going to give me, the numerator is 2, the denominator is 4, and I've got 2 of those. So let's see, this simplifies as 1/2, that simplifies as 1/2. Okay, so this is just, well, here, let's write some intermediate steps. So 1/2 plus 1/2 is 1. Square root of 1 is just 1. So what I know is that this distance equals 1. All right, so now let's check to see if it's really on the curve. If I plug in pi over 4 here, r equals cosine 8 times pi over 4 plus 1. So let's see what this is. So 8 divided by 4 is 2. So cosine of 2 pi, let's see, 2 pi is a full circle. cosine of an angle that's a full circle is just 1. So this gives me 1, but then I'm adding another one. So this R value is 2. So what I've learned is whatever this equation looks like when I graph it at an angle of pi over 4, the true point that's on this curve is actually at a distance of 2, but this is a distance of 1. And so I know that it's not a point on the curve. But I think all of the thinking was having the insight for how you can connect these two things together. And in order to have mathematical insight, you have to notice things, like the fact that these are the same, and then figure out why that's important. Noticing they're the same gives you the realization that the angle's pi over 4, and then you could think, what if I plugged in pi over 4? Then I could check to see what the true radius was. So a lot of solving math problems that are new to you involves sort of thinking about, what does this have to do with that? What does this have to do with that? Noticing things, thinking about the implications of what it is that you're noticing, and eventually you can sort of like piece little bits together until you have a solution. I hope that that was helpful.